Hello everyone. In this video, I am going to explain one more problem based on graphical convolution method. Now let us start the class. Now this is the question. Find the convolution of following signals like x of t is equal to t minus 1 of u of t minus 1 minus u of t minus 3 and h of t signal will be equal to u of t plus 1 minus 2 into u of t minus 2. So, before going to the steps of graphical convolution method, firstly we need to represent the signals regarding x of t and h of t. So, for that one, firstly here I am considering the unit step signal. So, this is the signal representing unit step signal u of t, and here this is the signal u of t minus 1. By considering the delayed operation by the time instant 1, we can draw the signal u of t minus 1 like this, and here is the signal u of t minus 3. Now this is the signal delayed by the time instant 3 from the original signal u of t. So this is the signal regarding u of t minus 3 signal. Now by doing subtraction operation between these two signals, we can find out the signal u of t minus 1 minus u of t minus 3 like this. Now here we need to represent the given x of t signal waveform. So here we need to consider again one more signal, that is ramp signal. So here this is the ramp signal I am considering, because here given in mathematical expression t minus 1. Actually the ramp signal equation is equal to t. So but here the ramp signal is delayed by the time instant 1. To verify that one, here I am using this expression. So by considering 2 points on this signal, by substituting these points in this equation, we may find out the mathematical expression for this signal r of t will be equal to t minus 1. So by multiplying this signal and this signal, we can find out the given x of t signal waveform is going to be in this manner. So the x of t signal is going to visible from the time instant 1 to 3 here. Now we will draw the signal h of t. Now for that one also, here I am considering the unit step signal u of t, and by doing advanced operation on this basic step signal, we are going to find u of t plus 1. So that signal can be like this, and here we are going to find u of t minus 2. Here we are doing delayed operation on basic step signal so that we can sketch u of t minus 2 signal will be like this. Now by doing subtraction operation in between this signal and this signal, we are going to find h of t signal as u of t plus 1 minus 2 into u of t minus 2. If we observe, the amplitude of u of t plus 1 will be 1 here, and amplitude of u of t minus 2 will be 2 here. So when we are doing subtraction, here from the time instant minus infinity to towards till minus 1, the amplitude is 0, and here from minus 1 time instant to 2 time instant, the amplitude is going to be 1 here, because here is a signal with 1 amplitude and here is the signal with 0 amplitude. By doing subtraction, 1 minus 0, so 1 can be found here. Next, from time instant 2 to towards plus infinity, we are going to find the amplitude as from 1 minus 2. Here we are doing subtraction, means here is the plus 1 amplitude, here is the plus 2 amplitude. But in between we are doing subtraction, means 1 minus 2 will be equal to minus 1. So the amplitude is going to be from time instant 2 to towards infinity minus 1. So this is the waveform for the signal h of t, we can draw like this. Now we will consider the steps of graphical convolution method. Now here in step 1, we need to represent x of t signal and h of t signal with the independent variable tau. So here this is the signal x of tau with independent variable tau, and this is the signal h of tau with independent variable tau here. After this, we need to find h of minus tau signal. So by doing time reversal operation, we find the h of minus tau signal can be like this. So here h of tau signal will be from -1 to plus infinity. The reversal signal h of minus tau is going to be from minus infinity to plus 1. So now we will move to the step 2. In step 2, we are going to represent both x of tau signal and h of t minus tau signal on same tau axis. Here we are going to consider the time shift t that will be the most negative number. So the h of t minus tau signal can be appear in second quadrant. So this is the signal x of tau and this is the signal h of t minus tau. And here h of minus tau, the limits are from minus infinity to plus 1. So here h of t minus tau here also minus infinity to t plus 1. Nothing but we are considering the time shift t that will be the most negative number. And here there is one discontinuity here at the time instant -2. That can be considered as t minus 2. So by considering both the signals on same tau axis, if we observe if there is overlapping area means we need to find out output signal y of t. By seeing this signal, we can say that there is no overlapping area till the time instant t less than 0. T less than 0, the output signal y of t will be equal to 0. Now we will understand with one example. By considering the time shift t is equal to -1 here. For example, t less than 0, here I consider one time shift here, that will be the t equal to -1. By considering this time shift, we can draw h of t minus tau signal can be like this. This is the h of t minus tau. In place of t, we are considering -1. So by that one, here t plus 1 means, t means -1 means -1 plus 1 will give 0. So this is the 0. And here t minus 2 means -1 minus 2 means -3. This is -3. And it is going towards minus infinity means it is also moving towards minus infinity. Now till t less than 0, there is no overlapping area. So output y of t will be equal to 0. Now if we move h of t minus tau signal towards the right side, we may find the overlapping area. Now we will move the h of t minus tau signal towards the right side. So by that one, we can find the overlapping area. So this is the graph regarding that one. And here I am considering the interval 0 less than or equal to t less than 2. So by that, for example, here I am considering the time shift t will be equal to 1. So by that, the h of t minus tau signal time instances are going to be, in place of t, if we substitute t equal to 1, we will find 2. Here also t minus 2 means -1. So here -1 and here will be 2. So there is an overlapping area in between x of tau and h of t minus tau. Here we can see, and if we find out the output signal y of t for this overlapping area, the integral limits can be from 1 to t plus 1 for both x of tau and h of t minus tau signal. By using this principle, by substituting integral limits, the x of tau equation is going to be tau minus 1 from this, and h of t minus tau is going to be 1. Here is the amplitude showing, and after doing integration, the output y of t signal we may find it as t square by 2 in the interval 0 less than or equal to t less than 2. Now, if we move further, the signal h of t minus tau, when the time shift in the interval 2 less than or equal to t less than 3, this is the overlapping area we may observe in between two signals x of tau and h of t minus tau. Now, for example, here I am considering t equal to 2.8, that will be the time shift t here for this h of t minus tau signal, and h of t minus tau, the time instance limits are going to be from minus infinity to t minus 2. So, by considering t equal to 2.8 here, we may observe this is the time instant at 0.8. So, this is the 0.8. Next, and towards t plus 1. So, in place of t, if we substitute 2.8 plus 1 means 3.8, we may find here. So, by considering these two signals x of tau and h of t minus tau, the integral limits are going to be from 1 to 3 for this overlapping area. If we do the integration for these equations, we may find output signal y of t will be equal to 2 in the interval 2 less than or equal to t less than 3. If we move further, the h of t minus tau signal in the interval 3 less than or equal to t less than 5. For example, if we consider the time shift t equal to 4, the h of t minus tau time instants are going to be minus infinity to t minus 2 to t plus 1. If we substitute in place of t equal to 4, we may find here 2 and we may find 5 here. So, this is the graph representing with the time shift t equal to 4 here. Now, if we want to find out the output signal y of t, the integral limits are going to be here from 1 to t minus 2. Here from 1 to t minus 2, this will be the time instant here. And expression for x of tau will be tau minus 1. And the amplitude of h of t minus tau will be minus 1 here. And now moving further, here the integral limits are from t minus 2 to 3. Here from integral limits t minus 2 to 3 here, the x of tau expression will be this one and h of t minus tau amplitude is going to be 1 here. Now by doing integration operation, we may find the output signal y of t will be equal to minus 6 t square plus 6t minus 7 in the interval 3 less than or equal to t less than 5. Now further moving h of t minus tau signal towards right side in the interval t greater than or equal to 5. For example, here I am considering t equal to 6 and h of t minus tau limits are going to be from minus infinity to t minus 2 to t plus 1. Here in place of t, if we substitute 6 here, we may find 4 and we may find 7 here. Now this is the graph showing regarding the time shift t equal to 6. Now to find out output signal y of t, here this is the mathematical expression for x of tau and this is the amplitude regarding h of t minus tau. It is showing in this graph here, and after doing integration by substituting integral limits, we may find output signal y of t will be equal to minus 2 when t greater than or equal to 5. Now for this problem, the mathematical expressions regarding the output signal y of t will be equal to 0 when t less than 0, y of t will be equal to t square by 2 when 0 less than or equal to t less than 2, y of t will be equal to 2 when 2 less than or equal to t less than 3, y of t will be equal to minus t square plus 6t minus 7 when 3 less than or equal to t less than 5, and y of t will be equal to minus 2 when t greater than or equal to 5. Now, by using these output mathematical expressions for the output signal y of t, we can find out the output signal waveform will be like this. Thank you for watching this video.